Bismillahirrahmanirrahim. Assalamualaikum and salam UiT di hatiku. To our beloved lecturer, Miss Wan Shahira binti Wan Ramli, as our lecturer for design and analysis of experiment. For this project, we choose completely randomized design (CRD), and for the experiment, we will do the donut dough. Alright, now let me introduce my group members first. First, we have Farah Yasmin binti Razali, Ainisa binti Muhammad Shah, Hani Atira binti Zainal Abidin, Nur Azwan Natasha binti Al-Wikuti, and the last one, me, Nurul Shuhaidah binti Ramlan Idrus.
Assalamualaikum, my name is Ainisa. For background of the study, yeast is an organism which needs food to grow. When yeast is added to dough, it produces carbon dioxide and alcohol during a process called fermentation. Due to the presence of carbon dioxide, this causes the dough to rise. We conducted an experiment to measure the rise of the dough with different amount of yeast being added into it. The time taken for the dough to rise is 1 hour. The height for the dough was measured by using a ruler in centimeters. For research question, there are 3 research questions for our research. First, is there any relationship between 3 different amounts of yeast and the rise of dough? Second, which amount of yeast that has the highest effect on the rise of dough? And lastly, is there any significant difference among different amount of yeast means?
Next, we have research objective. For our experiments, we have 3 objectives. First, determine the relationship between 3 amounts of yeast and the rise of dough. Second, to identify which amount of yeast has the highest effect on the rise of dough. And the last objective, to determine whether there is a significant difference among different amount of yeast.
There are 3 research hypotheses that can be found in this study. First, for Herschel, there is no relationship between 3 different amounts of yeast and the rise of dough. For alternative hypothesis, there is a relationship between 3 different amounts of yeast and the rise of dough. Second, for Herschel, there is no significant influence on the amount of yeast with the highest rising effect of the dough. For alternative hypothesis, there is a significant influence on the amount of yeast with the highest rising effect of the dough. The last one, for Herschel, there is no significant difference among different amounts of yeast means. For alternative hypothesis, there is a significant difference among different amounts of yeast means. For significance of study, donut sellers do not know how much should the amount of yeast be added to the donut dough. Therefore, this study is conducted to find out precise amount of yeast required to make the dough rise the highest. This experiment will also reduce and save the time to prepare for the dough once the best quantity of yeast is determined from this research.
And now we will be elaborating on Chapter 2, which is the research methodology. For the component of experimental design, firstly, the experimental unit is the donut dough. The response variable is the rise of donut dough. The factor is amount of yeast. For the treatments, 1 teaspoon, 1.5 teaspoon, and 2 teaspoon of yeast. The number of observation is 9. The experimental design that we will be using is completely randomized design, CRD, and lastly, the measurement unit used is teaspoon. Now, for the statistical model for CRD, the model for the data is Yij equals to mu plus tau I plus Eij, where I equals to 1, 2, 3 since the number of treatment is 3, and j equals to 1, 2, 3 because the number of replication is also 3, where Yij is the ij observation that represents the response, mu is the overall mean of the ith factor level. Factor level is known as treatment, so mu is overall mean of the treatment. Tau I is the ith treatment effect. Lastly, Eij is a random error. As usual, we assume there will be a random error every time we conduct an experiment.
I'm Hani Atira and I will be explaining the chapter 2.3, which is the assumptions of CRD. When one experiment uses CRD as their experimental design, there are a few assumptions that need to be taken into considerations. The first one is variance for all level of the factor is assumed to be constant, and the second one is the observations are mutually independent. The third one is with mean zero and variance, the model errors are considered to be independent and normally distributed. And the last one is tau I has a variance sigma squared tau and independent of Eij. For chapter 2.4, I will be explaining the advantages of using CRD as experimental design. The first one is CRD have complete flexibility, which allow us to use an unlimited number of treatments and replications. The second one is, although there are many variable replications and variable experimental errors of different treatments, it is still relatively easy to run a statistical analysis. The third one is, CRD provide a maximum number of degree of freedom for error for a given number of experimental units and treatments. And the last one is, analysis remains simple even when there are data missing. For chapter 2.5, I will be explaining the limitation that we've encountered in our study. The first limitation that we've encountered so far is the uncontrollable weather. Since our study have a lot of replication treatments, it takes a lot of time for us to run the experiment. During this duration, the weather have changed a couple of times, from sunny, rainy, thunder, and the humidity of the air might have affected the rise of the dough. The second limitation that we've counted so far is the inequivalent size of the bowl. Because this experiment has run by multiple, the size of the bowl might be varies. The base surface or the height of the bowl might be different, and this can supply us the inaccurate reading. Before we continue on to our experiment, to our study, the first thing we need to do is to prepare the experiment materials. The materials are cooking oil, salt, milk powder, margarine, measuring spoon, ruler, bowl, instant yeast, plain flour, caster sugar, potato, and egg. For chapter 2.7 is an experimental procedure, and this is a brief experimental procedure. I will be explaining in details in the next video.
The first thing what we need to do is to boil a potato and mash it. Then we can start to gather all of the other ingredients, start with the dry ones. We put in flour, milk powder, caster sugar, salt, and instant yeast. The instant yeast part is a bit tricky as we can't let the yeast to be intact with the salt too early, as it will die down the yeast reaction. Only then we can combine the dry ingredients with the wet ingredients, such as margarine, egg, potato that were mashed before, and cold water. Remember to add the cold water little by little. Knead all of the ingredients until it becomes a dough and take the measurement. After that, cover them with a clear plastic film and put it in inactive microwave to prevent changes of air humidity. After an hour, take it out and take the measurement again. Repeat the step with a different amount of yeast.
Next is the process of randomization. For this experiment, we have decided to use completely randomized design (CRD) since it is the simplest design that can be used in order to ensure the treatments are assigned to the experimental units completely at random. Along with that, this design also allows every experimental unit to have an equal probability of receiving a treatment. However, CRD is only appropriate when the experimental units are homogeneous. Furthermore, we can satisfy the independence assumption for ANOVA, that is to guarantee that the observation in each group are independent and they will be obtained by a random sample. Then, the process of randomization starts off with determining the treatment and experimental units. The treatment is amount of yeast, which are 1, 1.5, and 2 teaspoons, and the number of experimental units is 9. Secondly is to assign number to each of the experimental unit, which means 1 to 9. The third step is to find 9-digit random number from random number table. We chose block 2 and then rank the number in ascending order. The last step is to allocate treatment to the experimental unit. Thus, the table above shows the final arrangement for the experiment. The first experimental unit will be using 1.5 teaspoon of yeast, the second one will be using 2 teaspoons of yeast, and so on. Next is the method used to collect data. For this experiment, we collected data by observing and measuring the rise of donut dough. As you can see, in the fourth step, we took the first measurement of the dough after putting the dough in a bowl and before wrapping the bowl with clear plastic film. Then, we took the second measurement of the dough after letting it sit in the microwave for an hour. We repeated the process 3 more times to get the average reading. And lastly, the whole process from step 1 until 6 was repeated using different amount of yeast. And finally, this is the result of the experiment conducted. In order to achieve the result, the first measurement recorded for each donut dough are subtracted from the second measurement, and thus we get the rise of the dough. The rise of donut dough that use 1 teaspoon of yeast are 1.2 cm, 0.9 cm, and 0.9 cm. Next, the rise of donut dough that use 1.5 teaspoon of yeast are 5 cm, 4 cm, and 3.1 cm. And lastly, the rise of donut dough that use 2 teaspoons of yeast are 4.5 cm, 4.7 cm, and 3.9 cm.
Now, we're moving on to the chapter 3, which is data analysis. For the model adequacy checking, we have 3 assumptions that we observe. First is normality assumption, second is homogeneity of variance assumption, and last is independence assumption. So, for the first one, which is normality assumption, based on figure 3.1, it shows that all points lie along the straight line. Thus, it can be concluded that the residuals are normally distributed.
Next, second assumption is homogeneity of variance assumption. As shown in the figure 3.2, the homogeneity has been met because all the points are randomly scattered and there is no obvious pattern. Therefore, we can conclude that the error terms have a constant variance.
And the last assumption is the independence assumption. From figure 3.3, the pattern of the points are randomly scattered or has no pattern. So, this indicates that the error is independent. Therefore, the independent assumption is fulfilled and all the assumptions are satisfied. Next, 3.2 Treatment Effect. From table 3.3, it shows that the highest effect of the rise of dough on time taken is 1.0 tablespoon amount of yeast, since the value of treatment effect is 2.1333, which is the highest compared to other amount of yeast. 3.3 Testing the significance of the model. As we can see from the table, we can conclude to reject null hypothesis. The model is significant since the p-value, which is 0.001, is less than alpha value, which is 0.05. Thus, there is significant difference in the mean rise of dough between amounts of yeast. For multiple comparison tests, we use the t-test. As we can see from the table, for treatment 1.0 and treatment 1.5, the p-value is 0.002, which is less than the alpha value 0.05. Next, for the treatment 1.0 and treatment 2.0, the p-value also less than the alpha value, which is 0.001 less 0.05. But for the treatment 1.5 and treatment 2.0, the p-value is 0.787, which is more than the alpha value 0.05. So, we can conclude that there is a significant difference between all treatment except for the treatment 1.5 and treatment 2.0.
Now, let's move on to the last chapter, which is chapter 4, Conclusion and Recommendation. For conclusion, I will conclude it by objective. First, to determine the relationship between three amount of yeast and the rise of dough. Based on the result, there is a significant relationship between three amount of yeast and the rise of dough. Second, to identify which amount of yeast has the highest effect on the rise of dough. Based on the table treatment effect in Chapter 3, we can see that 1 teaspoon has the highest value of treatment effect. Hence, we can conclude that 1 teaspoon of yeast has the highest effect on the rise of dough compared to the other two amounts. And the last objective, to determine whether there is a significant difference among different amount of yeast. From multiple comparison tests, it shows that the p-value is 0.001. Therefore, we can conclude that the null hypothesis is rejected since p-value is less than alpha value, 0.05. So, there is a significant difference among different amount of yeast. And the last part, recommendation. If there is any students or researchers who want to conduct the same type of this experiment, I have one recommendation. What is it? It is you must use the square size of bowl when to put the dough. Why? It is because when we want to measure the height of dough, it will be more accurate. Why I say it's more accurate? Because the top of bowl and the bottom of bowl have the same diameters. But if you don't want to use a square size, you may use any size as long as the top and bottom of bowl have the same diameters. If the top diameter exceeds the bottom diameter, the measurement of height of dough will be less accurate. Alright, to make it more clear, I will share with you some examples. Now look at this, the top diameter exceeds the bottom diameter. So we need to avoid using these bowls. But for these bowls, as you can see, both top and bottom have same diameters. So we should use this. So that's all from us. Thank you everyone.